All right. Thank you so much, everyone, for attending today's roundtable, Food and Beverage Supply Chain Serialization and Traceability with Expero and TigerGraph. Just before we get started, wanted to go over a few items with everyone. There will be time at the end of the webinar for a Q&A, so feel free to leave your questions in the Q&A box at the bottom of your Zoom meeting or in the chats. We're recording today's session, and I'll be sending a follow-up email this week with a copy of the recording. It will also be posted to Expero's website. If you have any questions or need anything throughout the webinar, please feel free to reach out to Expero Internal. I'll be happy to assist. We hope you enjoy today's presentation. With that, I will go ahead and hand the mic over to Michael Shaler from TigerGraph.
Good morning, good evening, good afternoon, everyone. This is Michael Shaler. I run partnerships at TigerGraph, and I'm joined today by three outstanding panelists. We have Victor Lee, who runs our product strategy at TigerGraph, and he's also managing our community. Chris LaCava is the VP of product at Expero, and then Brian Thompson is the VP of Expero Adventures. And so we're really excited to have such a great topic and such great speakers today. Let's go to the next slide and talk about kind of where we're going with today's journey. So we're going to address supply chain challenges. Why do we need to change? Why now? We're going to talk about in detail how the legislative landscape is changing and how serialization and traceability are going to be absolutely critical for integrating the chain of custody tracking across supply chains. Then we're going to, and that would be presented by Brian Thompson. Then we'll transition to the art of the possible in terms of what it looks like and how our solution comes together. Chris is going to present that. And then we're going to close out with Victor Lee, who's going to talk about how to build a better supply chain with TigerGraph. And we're going to talk about both deep and multi-dependency analyses. And then we'll wrap up with a Q&A. And if you, as Laura said, if you do have any questions, please let us know in the Q&A box or chat. And let's dig in. So, obviously things changed last year. And one of the most dramatic things that changed for the supply chain team is the fact that we saw that the e-commerce acceleration that just transformed our society. We gained 10 years of acceleration in 8 weeks. And so now we have a new supply chain team and a new way of looking at things. So in context, let's dig into what that means from a back one, please. So e-commerce is up 41 billion, and this is the biggest disruption since World War II, impacting sourcing lead times and supply and demand variability. And we're not going to tell any toilet paper jokes today, but what's coming in 2021, and we're starting to see the need for this, and we're starting to see companies respond, is two dimensions: the resistance capacity and the recover capacity. So now we need three capabilities. We need to see, we need to connect, and we need to act. Next slide, please. As we move forward, I feel very, very grateful to all the scientists and all the people who've made it possible for me to get my two Fauci ouchies. I'm on Team Pfizer, and I'm so grateful to feel like we're in a better place and we can overcome all the challenges that are in our way. Click. So again, just to reiterate, it's all about the right architecture, the methodologies, and flexibility and plan for growth. That means we can see, connect, and act. Let's double click on this. First of all, we can actually build an enriched supply chain graph. Okay, so we can take all the data sources that exist from all the legacy systems, all the signals, all the IoT devices, and then we can actually connect them by enriching the graph with a combination of cost factors, risk factors, and constraints. There are legal, time, capacity, and governance constraints that are going to be vitally important in the supply chain of the near future. Step 3 is we're going to need to connect deeper, and we're going to build out a visualization system that enables human exploratory learning and unsupervised machine learning. That means we can run graph algorithms. We can actually build out the graph plus ML capability to optimize decisions, operations, and outcomes in completely new ways. So it's really exciting to see we have a new approach because we're looking at connected data for connected insights and we can take action in entirely new ways. Next slide, please. So Gartner has highlighted how very important graph analytics are. You can see the top 20 trends of 2020, 2021. And again, the graph analytics help us see, connect, and act in new ways for more effective outcomes. Click. So we're going to talk a bit about TigerGraph, and then we're going to hand it off to Brian from Expero, and we're going to go talk more about Expero as well. TigerGraph is the only scalable graph database for the enterprise. We were founded in 2012. We're in stealth mode for 5 years. We're based in Silicon Valley, and the crown jewels of what we offer is GSQL, Graph Structured Query Language. It is the best home for AI and ML. It enables graph algorithms and enables us to answer the best questions about connected data with fast, deep, and wide insights. And we're delighted to see our customers embrace this approach. And we're spanning multiple vertical markets, multiple use cases. And Forrester and Gartner are noticing. Forrester has declared us, even though we're a relatively small company, a leader in graph data platforms. And Gartner has said that we're a cool vendor. And so we're very grateful for their highlighting the importance of what we're doing and the outcomes that customers are driving toward. Click. So again, let's talk about business cases, solution pieces, and machine learning analytics. You can go through you can see into source and material management, capacity planning, material flow, bottleneck detection, and inventory optimization. And Chris is going to show us what that looks like. In terms of the solution pieces, we can deploy anywhere, on the cloud, on premise, and we can enable complex visualizations and understand the dependencies, paths, routing, and visualization that make it possible to see and ask what if. And that means we can do root cause and investigations, we can do network mapping, we can do dynamic routing. And that means that we can then take action through the power of machine learning and analytics to drive completely different outcomes in terms of decision trees, target similarities, audit and compliance, scoring and risk. And so then we can start to actually take apart the digital twin that is representing our supply chain across all the spaces and places that we need to go. Click. In terms of kind of what this looks like from a platform perspective, TigerGraph is in the middle, but we can deploy anywhere. We have all the source data systems, databases, data warehouses, and data sets on the left, as well as IoT feeds and others. And on the right, you have all the consumption endpoints in terms of algorithms, analytics, and then applications that leverage that. Now, what we've added here on top of the TigerGraph core is the TigerGraph toolkit. Click. And what that enables is to have visibility into all of the aspects that are critical for executives, planners, analysts, and IT. So we provide a holistic view of that digital twin that represents our supply chain, and we're enabling it to be a much more powerful approach to how we're doing things. Click. Why now? Well, the risks are immense, and the rewards are too. The pressure to do more with less. In the age of COVID, it's never been higher. The risk exposure to a do nothing approach has also never been higher. So we need to cut costs, protect money, and drive revenue with happier customers. And supply chain touches all of those. The disruption, lack of visibility, how clearly illustrated that has been during this pandemic. The rewards that are part of those, that respond to those risks, taking on those risks and doing something now means that you can implement it in weeks, and it's going to be much less expensive and much more effective than traditional systems. And we're going to talk about that in a little bit more detail when Brian comes on in a moment. But the thing is, we can also integrate in with legacy technologies such as SAP and Oracle, and then we can leverage the current technology and augment with higher higher accuracy and better analytics, better outcomes. A tremendous amount of business value is possible by taking on this approach now. Click. Excuse me. I'm now going to hand this over to Brian, and he's going to take us down the path of talking about serialization and traceability and the FSMA and how to integrate chain of custody tracking. Over to you, Brian.
Thanks, Michael. Good day, everybody. This is Brian, and I'm going to start today by talking a little bit about the FDA's Food Safety Modernization Act, or the FSMA. We're going to talk a little bit about this, and then just from a background standpoint and some of the challenges associated with it. And then we'll tie that in, as Michael said, with some of the art of the possible, with ways to address some of the things that come out through this. So the FSMA was originally enacted in 2011, and we'll talk more about the overall timeline behind the act in a minute. But Congress enacted this in response to basically our growing understanding of foodborne illness and especially its consequences. So each year, about 48 million people in the US, which is roughly 1 in 6 people, get sick. Of those, about 128,000 end up in the hospital. And there are actually about 3,000 people that die each year from foodborne illnesses. So it's an issue definitely worth addressing. The major elements in the law can be divided into about 5 categories. Those are preventative controls, inspection and compliance, import food safety, a response to these issues, and then last is a set of enhanced partnerships to help with all the problems. As we look into the next slide, we'll see a little bit more about the timeline. As I mentioned, it was enacted in 2011, but most of the rules were created and then finalized by the end of 2015 that were going to govern the actions that need to take place. And then most businesses are actually already in compliance with those rules now, though there are some smaller, and it's kind of staged out based on the size of the business and the size of the farm, and then a couple different areas. And so what's left really remains at some of the very small farms, and they have until 2023 to finalize the last elements of their compliance. But the FSMA in general has actually already dramatically changed the regulatory oversight for both produce and food imports. And this includes regulatory standards for growing, for harvesting, packing, and even holding foods, like fruits and vegetables. It also makes importers responsible for verifying that their foreign suppliers are meeting the new FDA safety standards. And there's even a program now for third-party auditors to perform food and safety auditing of actual foreign entities to get the full picture of the food supply chain covered. And with most large businesses now in compliance, the FDA actually announced the new era of Smarter Food Safety Initiative. And that happened in April of 2019. And the purpose behind that is to create an even more digital and specifically more traceable, safer food system. So they followed that announcement up in July of 2020 with the blueprint. And the blueprint, which we'll spend a little bit more time today talking about, creates another 10-year roadmap for reaching the goals behind the new era of smarter food safety. So the blueprint encourages and even incentivizes industries to voluntarily adopt new technologies that lead to end-to-end traceability. Which ultimately, is in the direction of providing further protections for consumers against contaminated food. As we look at the next slide, we'll look a little bit more specifically at the blueprint. There's really 4 core elements of the blueprint. The first is tech-enabled traceability, and we'll spend more time on that because traceability is definitely a key part of the solution here and some of the advantages of TigerGraph. The second element is smarter tools and in general, smarter approaches to preventing and responding to outbreaks. And that's really about using that traceability for better root cause analysis and ultimately improving the path to prevention. The third element has to do with new business models and retail modernization, and that really is about, how do we adapt to support this move to things like online grocery services, and then the accompanying delivery process that happens, and how do we manage that process to keep that food safe throughout the process. And then the final element in the blueprint has to do with, in general, the food safety culture, and that's really about keeping food workers safe, and then also educating those of us who are cooking more at home, making sure that we're handling our food safely. So in the next slide, we'll talk about tech-enabled traceability. I think the kind of, those of you in the space are kind of used to this, but maybe it's a little surprising. But most of the records involved in moving food through the supply chain are still largely paper-based. So this obviously lends itself, it becomes challenging as we try to digitize, but the fact that they're paper-based and then accompanied with just a general insufficient data availability to help us identify what the actual products are and how they move through the supply chain, just generally makes it difficult to track and to trace food. So during an outbreak, that lack of sort of digital real-time information availability, it can cost lives. It definitely costs millions of dollars in product losses, and certainly also damage to consumer trust. So all things that we want to look to avoid and improve on. And we've seen this, with recent outbreaks in, things like, especially around like fresh leafy greens, come to mind over the last several years, and certainly the last decade. And it's really about the fact that there's a lot of anonymous folks and a lack of traceability in that system. And with those elements, and that lack of information, it really prevents us from rapidly tracing back and identifying contaminated foods. So this specific element of the blueprint has three areas of focus to help with these issues, right? The first one is a foundational set of components, and that's about standardizing standardizing data elements, and then standardizing the way that we track events. The second is around adopting new technologies. So these are specifically to allow food producers, really of any size, to access scalable, cost-effective technologies. And the third is digital transformation, right? We need to accelerate traceability through digital technology systems that can receive real-time tracking and tracing events, and then the key data elements from all folks in the industry and their regulatory partners. In the next slide, what we'll see, and this is kind of what we're hearing from folks that are either becoming more and more compliant or have made it further through this process, is that as they've become more compliant, they're realizing that there are many new capabilities that they can exploit as a result of pursuing the compliance with the original act, but also starting to fulfill the items in the blueprint. And so these things include, better real-time insight into the product chain of custody, which also leads to better inventory management as we understand where all the elements are at various points in time. It allows us to manage a better rebate programs and more accurate handling of those. And then I think, maybe most importantly, narrower recalls, so we can really focus in on what we need to take off the shelves. Let's talk for a minute about some of the challenges behind, pursuing these goals. There's a whole number of them here, but I think there's three categories that we hear most common and are kind of worth spending a second on. As we move into the next slide, we'll talk about data management. And Here, what we're talking about is, bringing all this data together. There are folks who pursue this in a centralized way, which can be expensive. There are folks that actually try to do this in a decentralized way, which can be a little bit difficult to scale. But the bottom line here is that we're going to bring together a lot of data. In some cases, the transactional data itself is just a large volume, but as we bring that data together over time, which there's a lot of value in having the historical information as far as finding insights and learning from it, we end up with a lot of data. And so what we need is a system that can handle that data load in a way that allows us to really take advantage of the data and make real-time decisions. The next element that we hear as a challenge, I think probably as commonly as the data challenge, is actually integration of that data. So that data is spread out in a variety of different systems that need to be brought together, but we need to do that in a way where we can connect those legacy systems with the new solutions that we're bringing to bear that help us with the traceability and the serialization. So it's important to be able to support the integration needs that we have here. And then finally, the last one really has to do with the complexity of the relationships involved with this data. So, if we think about, from suppliers and raw materials to the ingredients that are needed, and then the intermediates that are created through a process that turn into finished goods, and then overlaying that entire layer with the suppliers, the manufacturers, the repackagers, wholesalers, distributors, third parties that are involved. We want to understand where each one of these pieces is and who the actors are that are associated with it, and we all need to see that based on time. And as we move through time, as to see those relationships change and to be able to learn from them. So there's a complexity of relationships that are that's behind this. So what we're going to transition to here is a little bit about solution, right? This is a little bit about problem. Let's talk a little bit about solution. We're going to talk about taking the power of TigerGraph and exposing that through a highly configurable visualization toolkit that we've built here at Expero. And we apply this toolkit in a couple of different industries, but today we're really going to focus in on the supply chain and showing you how we can take this toolkit and help with this traceability problem and this root cause analysis problem. And with that, I'm going to turn it over to Chris, who's going to demonstrate that for us.
Thanks, Brian. As Brian mentioned, we're going to walk through a few examples of data analytics tools that we've built with this SDK on top of TigerGraph. And we're really going to zoom into, first of all, the visibility issue, because that's always the first step in traceability, is just being able to stitch some of those legacy systems that Michael had mentioned together in a unified connected data set in TigerGraph, and then we can start to analyze it. And then once we are able to analyze it, we can get into some predictive measures. And so we'll show things like being able to proactively look upstream and downstream at potential issues, as well as mitigating risk once we identify that risk through basically traversal of that networked data. So I will jump into a demo here. And we will look at a kind of a 3-mile high overview first of this connected data set. So we can look at what at first blush looks like basic KPIs for a supply chain. We've got demand information here over time. We've got revenue information and some regional sales information, as well as something that's a little bit different here, which is risk categories. So this information overlaid over some of these other more standard measures is really at the heart of what we're talking about. We can basically build a composite set of risks once we can lay out the topology of that highly connected data set. So when we pull data from various locations, various legacy systems that are siloed, such as the ERP, as well as other information, maybe sales sensing information, and we unify that within a graph database, then we can start to look at it holistically. And we can start to look at things like inventory shortage or utilization or even compliance. So in this case, we want to look at compliance measures for sure, or various disruptions. So if for example there's an outbreak, that could be categorized as a disruption, and we can spider through some of that information and try to look at our risk from a high level. We can configure this because since that data is managed within one storage media, we can start to overlay weights on that and start to run analysis on it. So we can attenuate this risk profile by either taking things out or weighting things higher than others, and that will shift that risk profile. And that will trickle through all of these data visualizations that we're looking at. So for example, if we really wanted to weight compliance around some of the measures that Brian mentioned, for example, around the regulatory aspects of food safety, we can now use that to go through multiple sets of analytics, and that risk will color all of the things that we see in real time, and even give us some remediation recommendations. We're always looking at this data through time. So in this case, if I'm a rough cut planner, for example, I could be looking at this information in a forward-looking format, and I can even attenuate it by where I want to look over some kind of trend over time. In this case, it's demand. I can also look at KPIs, so I can always keep front and center some of the KPIs that I'm looking for around risk, and I can even drill into more granular views of this data. So if I want to look at, for example, here we have finished goods, I can click through to a specific finished good and see how that risk looks across the bill of materials. So in this case, I'm looking at the finished good at the top here, and then all the major parts that make up that finished good, all the ingredients or components. And I see here, based on my risk coefficient that I've just configured, in this period of time, that yes, in fact, there are risky items. And I can even see what that may look like. So if I've got demand issues or if I've got compliance issues, I can bring that to the surface. So you can start to really see how you can, just by virtue of pulling that information together, you can gain visibility and start to build proactive plans and even look into the future. So the next thing I want to look at is basically how we take that high-level information, bubble it up, and then drive down and build remediation. So this is where the predictive analysis may come into play, and or looking at upstream and downstream remediation, hopefully proactively. So just like the prior screen that we looked at, we also have certain types of risk with that same coefficient that we're pulling together around its constituent parts. So all those different things that make up that risk. I can also look at this through various other things such as demand and capacity. But what I'm going to go ahead and do is actually look at where I have risk around products, specifically in compliance. So here I have a couple of components out of compliance, actually finished goods with components that are out of compliance. So I'm going to drill into one of those and see what the issue is. And yes, sure enough, there is a compliance issue with this one component that makes up this finished good. And I can look at it. In this case, we're looking at consumer electronics, but the same type of remediation would apply to almost any supply chain with this issue. So I can see with the compliance threshold issue that was tripped, I can look at more detail there and look at it. I can see where there are different alternatives to maybe substitute that component. And then I can add this component to a watch list, or I can find other components within that connected data that may have the same kind of issues as this. But in this case, I'm going to build a what if scenario. So I've got my supply chain here from sourcing all the way through to distribution. And I've got my high level bill of materials here with my issue component. And I'm just going to remove it and see what that would do to my supply chain. And sure enough, I've got inventory coverage issues downstream because this component is removed. So obviously we don't want to do that. We can go through and we can also look at other measures like capacity, and we can also look at how that component filters out through distribution in its different phases in different regions. So, for example, I've got some finished goods out in certain regions that are already delivered to the customer. Some of them are in distribution, and some of them are in manufacturing, and some of them are just planned. So I can start to build a remediation plan based on the fact of how much of that stuff is out in the wild. I can also look at how I may be able to remediate certain flows through resources. We'll look at that in another solution in just a minute. And I can also go through and find a replacement part basically and remediate that supply chain now that I have a plan to see how I could basically flow through and address some of the coverage issues that we saw before with just removing that component opposed to actually replacing it with one that will work equally as well or the same type of ingredient but sourced from a different supplier. One more set of applications that we've used for the toolkit that Brian and Michael mentioned earlier. Again, I have a list of finished goods here, looking at it over time, same kind of patterns. This time I'm really going to look into the network and see how the flow health, that being the amount of material flowing through the manufacturing process, looks over time. And I can look at this from a set of either a piece of the bill of component of the bill of materials, or I can look at it through all the components. So in this case, what I'm looking at here is the stages of manufacturing, from active ingredient to formulation, packaging, through distribution, and how that material flows from one location to another over time. Again, that stitched together set of data. And the lines here represent the health of that flow of material. So do I have enough capacity to basically bring this, to transform this product from active ingredient to formulation and so on and so forth? Do I have enough material projected to ship from one place to another? It's where that predictive analysis comes in. And so the color is basically telling me if I have scheduling issues, or I have compliance issues, or if I have any kind of set of inventory bottleneck between the locations. That's what the color represents. The thickness of the line is the volume of material moving back and forth. So I can see here I have some bottlenecks. I can click into this and remediate it. It would walk me through a very similar scenario-based process that we just saw on the other screen. But this is just another example of once the data is holistically pulled together, we can start to do analysis, flow analysis, and in this case, into the future to look at that predictive aspects of analysis. So just to recap, we looked at our take on planning tools, supply chain planning tools. Most of the stuff that we were showing was in the future and therefore used for more planning purposes, but this could just as easily be used forensically or to look at operational aspects of things happening in real time. But nonetheless, the solutions we were just looking at basically use these things that we called active scenario, traversing that information within the graph, using algorithms to gain insight, and then build remediation. Or just what if analysis, what if demand increases, what if we add another location to our facility for packaging. And it looks at that information on two different axes. One is material flow health. Am I getting the right inventory to the right place at the right time? And then resource capacity planning. am I able to turn that material once I get it to the right location to the next phase of manufacturing, because do I have enough capacity basically to transform that item? So that's basically the three legs that we use to be able to do a lot of this analysis on the highly connected data model. You kind of saw the holistic risk scoring that I mentioned. That is where we can inject both unsupervised and supervised learning algorithms. So that's where graph data and machine learning really come together. It manifests itself in a lot of these risk and recommendation engines, but you kind of saw the surface of that. I think Victor will touch a little bit more on that as he digs into basically how TigerGraph is modernizing supply chain solutions. And then obviously we talked a little bit about compliance and how we can use that connected data set to build out the essentially digital twin of the supply chain, and then see the upstream and downstream effects proactively of certain strategies around replacing items or removing items from the supply chain. And I'll hand it over to Victor now, and he'll go through building a better supply chain with TigerGraph.
Thank you, Chris. So you've heard a lot from Michael and Brian and Chris about what are the challenges, about some of the regulations, the landscape for food and beverage supply chain, and then Chris did a great job of talking about the art of the possible. I'm going to talk about how we can integrate this with a graph database, particularly one like TigerGraph, so that you could take advantage of this capability to help your business. Next slide, please. Sorry for the background sound. So, here's trying to walk you through some steps. Identify your current needs, anticipate what your future needs and scale will be, understand differences among different graph platforms, and then consider graph-based machine learning. So the first step is, you identify what data you're going to put in your graph. And the key is that this technology enables you to have a really multifaceted or multidimensional supply chain. You could think of it in tiers like this for simplicity, such starting with the farmers and the food sources at the very bottom, then some processors, distributors, and retail outlets. But it's actually even more complex than that. The tiers are taking into account that at each of those levels, they each have factors and relationships and details, such as, just looking at the food production layer, you are describing the different crops, their locations. You're taking the weather into account. You're taking into all sorts of different factors and labor costs, and then every layer has those things. There are legal constraints. There are things that are simply contracts between different businesses, so private contracts. There are government regulations. Each of those can be expressed as a graph relationship. And the really nice thing about the graph is that it's easily expandable. You can start with the model that you feel comfortable with, and you can continually add more factors to make a richer and richer graph. Next slide, please. So using this technology, you can first, maybe one click, build your graph to connect everything. As we said, you take in this case, the product, you have both the end products, the finished food and beverages that you're selling, starting from the raw ingredients. You have all the processes. So you build your master graph that describes everything. Next, click, we can analyze. You can first model just when things are working well, how long does it take to get, what is my expected output supply, and so what is the basic time and cost to produce that, and you can try to look at what you think you might be able to sell it for. And each business is involved with some subset of the part. If you are a company like, Del Monte, or one of the companies that is involved at every aspect, then you're going to be looking at this analysis to try to, well, where are my risk points, as Chris pointed out. Can I do predictive modeling? Um, and you can explore what if scenarios. You can plan for possible disruptions. And lastly, one more click, you can do a machine learning. As he mentioned, there are some techniques that you can do with traditional operational research type, just solving optimization questions. But sometimes, to dig deeper, you really want modern machine learning. And there are some wonderful graph-based algorithms, graph features, and even graph neural networks that can be used to really give you much deeper insight. This is a really exciting time when there's so much research going on with graphs, that you can do a lot more, not just because the graph platforms are more performant like TigerGraph, but the techniques have become more advanced. So this is really a sort of a golden age for graph analytics, and to be able to take advantage of it. So one thing you want to take into account when you're planning your system, we talked about modeling your data, and you start with what you understand and you can enrich it as you go. Scalability, as I said, you're going to be bringing in data from multiple sources. So you may not have ever had all your data in one place before. So like this, so it may be a little bigger than you're used to having. So you want to make sure you're picking a platform that's scalable. And as I said, you're going to want to add, you'll probably decide to add more to it. You're probably also going to start to track historical data. So the data is going to grow over time. So you're going to want a scalable system, a system such as TigerGraph, which is a distributed graph, and so that the performance keeps up as it scales. Next slide. You also want to be able to do the analytics that you want to do to get deep analytics and real time. The way that you do things on a graph is to start from one set of nodes and follow the connections and follow the connections. A supply chain, by its nature, if you want to analyze the full thing, you start from one end, the source, and go all the way to the final goods. So you're exploring the entire graph. You need a system that can handle that sort of full graph analysis. You want to start with something that is a so-called native graph, that is, it's designed from the ground up to be a graph database, so that you get the right performance characteristics. There are some other products out there which present themselves as a graph, but they're really built on a different type of database. And when they're built on a different type of database, you're not going to get the performance characteristics that you're looking for. You need that real-time capability and something that's designed to do the type of parallel execution, sort of breadth first search, so-called, and with sort of built-in computational ability. TigerGraph sort of does local computation at every node, so that you can get those real-time results. It can make a real difference. One of our supply chain customers, they transformed one of their analyses. With the old system pre-graph, it was taking 3 weeks. With TigerGraph, it now takes 45 minutes. So it can make 100-fold factor of difference in time if you have the right platform. Next, and again, you want to make sure it's not just fast, but it's designed for the right type of workload. There are transactional databases, which TigerGraph can do transactions. There are analytical databases. TigerGraph is very good at analytics. And that comes down to not just the way it executes, but the query language. Our query language is designed to handle algorithms. I've got a little picture of what our PageRank algorithm looks like. That's actual GSQL code. If you are a coder who knows graph algorithms, if you studied PageRank in school, that looks very much like the pseudocode description they gave you, so you can directly, with very little effort, take a standard algorithm and write it in GSQL. And that's the beauty of it, that you don't have to rely on just the ones that we've prepackaged for you. Um, you can take one of our prepackaged ones and you can tweak it, or we can work with you, or your developers can work by themselves to take a new algorithm, a new analysis. You don't have to think of it as an algorithm. You can just think of it as a query or analysis that you want to do. So that's one reason why TigerGraph is suitable for machine learning. It's sort of the combination of the parallelism and the programmability. And I think that takes us, here's just an example of some of the algorithms that are available and that people really do use for this type of work. Um, Obviously, path analysis is very relevant in a supply chain, but also things, if you're looking for risk areas, things like looking at centrality and page rank are actually very important for risk-based. And then similarity algorithms are very important. Once you find a area of interest, you want to find, are there any other areas like that where I decided to take some action over here, I should take a similar action wherever I see that pattern. And there on the right column, I mentioned some of these new graph-based machine learning techniques, or just general techniques, which you can take the enriched data you get from a graph and do some of these advanced machine learning techniques. Okay, and then another great thing about graphs is the ability to do explainable AI. And that's where, and that's become very important in the analytics industry and for businesses. There are some of the new techniques, they come up with answers, but their their approach is so synthetic, and with so-called hidden layers and hidden variables, which have no correlation to the real world, that it's hard to, you have to put a lot of trust into that model, because if anything wasn't quite right, then it could get a completely wrong answer. If you're using graph-based features, due to the semantic modeling, where the relationships have real world meaning and the objects, the entities have real world meaning, when you describe your graph features in terms of those little features, like who is, which supplier is able to, has the fastest throughput, and it distributes to the widest region. So that's when you can give it a ranking score based on that. When you build up your analysis based on these explainable features, then your solution is explainable, and that's a great benefit, and that's something that a lot of businesses like yours perhaps are really looking for. They don't want just advanced analytics, but they want explainable analytics. And here's just sort of, as we're getting towards wrapping up, I want to sort of give a high level outline of how you use a graph database like TigerGraph together with a dashboard and analytics interface like Expero to deliver this sort of advanced performance. So you start by bringing your data, point number one, into the graph. Two, you can run queries and algorithms which enrich the data. So you have your original raw data, and then you add more properties or more relationships based on what's already there. You do some basically essentially pattern detection and scoring to make the data even richer. And then three, you do your machine learning training. And fourth, you deploy your explainable ML AI model, where you run an analysis on the graph. So you use the graph both for phase three, the training, or possibly you could export the data and do it elsewhere. Both approaches are fine, but this approach is using in-graph database training. And then four, you deploy it there, where from your dashboard you do your analytics. and this is just to summarize the things I've said. You want to find a platform that's scalable. You want to find one that can do the real-time deep link querying. And because that's going to be able to bring all your data together, it's going to break down the silos. It's going to give you that visibility that you haven't had before. And it's going to be able to answer the questions, again, that you weren't able to answer before, either because you simply didn't have all the data in one place, but you also have to make sure you have the performance so that it can handle all that data and do analytics. The ability to do machine learning by having the right processing engine and the right query language so that you can implement those algorithms. And great thing about having a platform like Expero is you can do a lot of this work with no code. You can bring the data in, you can investigate it, you can run your analysis without writing any code. And lastly, so to wrap up, want to thank you for your time. Thank my fellow speakers. You can check out TigerGraph at tigergraph.com/cloud. I think the next slide shows a lot more ways you can contact the rest of us. Any of us would be happy to answer your questions, either right now or in the future. You can go to either of our company websites to see TigerGraph starter kits, to see Expero demos. We've got, in particular, of relevance is the Jaguar Land Rover supply chain example. And so you can welcome to talk to either of us. So thank you for your time.
Yeah, thank you so much to our panel here. I just wanted to go over a few questions that came throughout the webinar. Let's see. And just as a reminder, if you do have any questions, feel free to drop them in the Q&A. But the first one is, a knowledge graph or a property graph better for supply chain?
Okay, well, I'll take that one. I would say I don't want to be put down knowledge graph. Knowledge graph is really good for logical reasoning, but that's really not the workload here. The workload here is much more computational analysis. We're not doing logical reasoning. We know what we're doing already. We know what we're producing. What you're trying to see, is it going to work, and at what cost and at what time? And that's where the more analytical approach of a property graph is more appropriate.
And another question that came up was, we were asked, what's the difference between, how are TigerGraph and Expero different? We're partners. TigerGraph is the graph database that is the analytics engine underneath the solution that Brian talked about, that Christopher showed, and Expero builds that front end and adds the expert services to ensure that customers are able to deliver a supply chain solution in a very, very powerful way.
Thanks, Michael. Another one that came through, do these solutions demonstrated work within my existing supply chain or ERP system topology?
I can jump in there. For the customers that we've worked with, and I would really expect this to be true for most everyone, we fit within the general system topology. So lots of customers of ours are on SAP's, Oracle, JDA, from an ERP and supply chain management solution standpoint. Many of them have inventory management systems and the advanced planning systems, and effectively that data is spread out amongst those systems, which is part of the problem. And really what we do is layer on top. And I'll let Victor talk about that in the case of TigerGraph, where we've seen, in our experience, we've seen similar behavior there. But I guess the part that we generally replace is really the Excel spreadsheets, and the individual systems that some of the business units have put in place to deal with the fact that they can't get the data out of their master systems. And so generally speaking, we're just working in conjunction and in concert with the master systems.
Yeah, I just sort of reinforce that message. So we're not necessarily, replacing the ERP, but we can talk to and integrate very well. We have a number of connectors for, bringing data in. And, once it's set up, it's we have real-time ingestion, so we can keep up to date with things that, anything, if you have IoT data from trucking, or from the, if you're tracking, the commodities prices and need to know that, you can bring whatever data you want. We've got, it's pretty easy.
Another question that was asked just now is TigerGraph like business intelligence? And the short answer is that we are basically graph analytics. So yes, we're like advanced BI, advanced analytics. We can work with SAP, as Victor just said. We can work with other ERP systems, and we can leverage that data that exists in those databases, data warehouses, or data sets, and bring that into the graph and visualize it, and then do analytics on it, machine learning, and deliver this full solution.
Thank you, Michael. And then we did have one last one come through. Would this solution be able to model the effect of food safety recalls? And what about taking preventative action?
Yeah, I'm not stepping on their toes. I think Brian or Chris mentioned that in their presentation. So I don't know if they want to go any more depth, but I think they did say yes, they could. We can.
Yeah, I can chime in too, Victor, just to add a little bit more color on that. The systems that we demoed that were built on the SDK, using that connected data set from TigerGraph, are used for predictive analysis, exactly like the question mentions. So it's not only used for prediction, but that's a very strong use case. And so using that connected data set and the analytics tools that we looked at showed upstream and downstream effects of highly complex connected networks such as food safety recall, and being able to model that stuff proactively.
Very cool.
Great. Well, that puts us just at about time. Just want to thank everybody again for joining today's webinar. Just as another quick reminder, we will send out an email later this week with a copy of the recording. If you have any questions, please feel free to reply to that email and we'll get you set up with the right people. Thanks again, and I hope everyone has a great rest of your day.
Thank you so much.
Thank you.
Oh.